Claude Shannon devised a way of managing the smallest quantity of information and called it a bit. The rest is, well, history. Subscribe now to our series, The History of Math, in the YouTube channel What Makes It Tick. Thermodynamics, the science of heat, was developed dozens of years after the first steam machine. So the theory came after the tool. And strange enough, the same happened with information. The first calculating machines were designed centuries ago, but one day after World War II, somebody called Claude Shannon thought, okay, I'd like to develop the science of information, exactly like the thermodynamics, but this time it's called information theory. And when you develop thermodynamics, you need units to measure heat, like the calorie. That's the way how Shannon started. Say, if I want to develop the science of information theory, I need a unit. And he came with an interesting question, which is the minimum quantity of information possible? And the answer is the outcome of a very simple experiment with only two possible outcomes. Like the toss of a coin. If you take a coin, you flip the coin, I give you the answer, this is head. So I provide you with some information. It's the smallest information possible, the outcome of an experiment with only two possibilities. And that's how we connect with 0 and 1. So many people like Boole, we saw in the former video, define the binary system as a world organized around zeros and 1. But for Shannon, the bit binary unit, it was for him the minimum quantity of information possible. It's another way to define the bit. Then he went one step further. If I take a dice and I roll the dice and I see this is a 5, I provide you with the answer, it's a 5. I give you more information than the head of the coin. And that's how he connected information and probability. The highest probability, the smallest the information. And finally, he said, wow, I'm gonna do the two experiments at once. I have in my hand the coin and the dice. I throw them both and I have an outcome, head and 5. In fact, the information is the same if you have only one throw with the two objects or two different throws. And that's how he came to this formula you can see on the screen. And the only way to solve this formula is to introduce the idea of logarithm. And that's how Shannon connected information, probability, and logarithm. And again, we are connecting some concepts. And the more we go into those videos, the more you'll see things are connected together, because in the end, mathematics is a huge set of connected concepts. Join us next time to understand how an ant's perspective led to the discovery of fractal geometry. And subscribe now to follow our series on the history of math in the YouTube channel What Makes It Tick.